Yo, what up? Welcome to Made by Ozzy. I'm Ozzy, and today I want to do a little recap, a little summary of everything we've built over the last few videos. So we've been working on turning this development kit into both the cryptocurrency miner and a GPU. And so far, what we have working is the communication interface to it. We have an RS-32 all wired up and working. And so today I just want to take some time. I want to go over and show the new viewer quickly the repo that we have, how to use the information in it, and what you could reasonably expect. So let's get started. Okay, so what have we actually got here with all these videos that we've made? So all of these videos have been working towards populating this GitHub repo. And this GitHub repo gets you everything in this folder here, basically in this copper folder. We have some documentation, the user's manual for the development kit and the FPGA folder for the actual Cordis project and all of the Verilog modules, and a little Python folder for some test Python scripts. So here's the Cordis project with the top level entity, copper.pdf. It's a schematic diagram file, and here are all the modules written in Verilog. You could open them up and take a look at the actual source code, and I actually went ahead and left a comment. Every single module has a video explaining every single line, and so I went and added which video to reference for that specific module, and of course my crypto receive addresses if you feel like helping this development effort. I also have madebyozzy.com where you could go get some reference material when you need it, like all the videos for setting up the RS-32 and the relevant GitHub lobs to reference for that. Of course, all my crypto receive addresses if you feel like helping me out with this development effort. If you don't want to look into the development of the Verilog modules, you could always go directly to the output files, and you have access to this SOF, which you can use to program the board. You come over here to Tools, open up a programmer, and then you got here, and you could program out that copper.sof file to your board. And then once you have the FPGA loaded with that SOF file, you have this test Python script to test the RS-32 channel, which we currently have working on that development kit. So if we write out the binary string, or the ASCII characters 4, 5, 6, we expect to see the hexadecimal characters 34, 35, 36. And indeed, we see 34, 35, 36 on the 7-segment display hex decoder, which we set up in a previous video. And there's also a video showing how all of this hardware was connected. Okay, so we have a full communication channel, all working, all tested. We got scripts to work with, everything worked out. So that's going to draw a nice conclusion to this FPGA Essentials series. The next series that's going to start with the next video is the crypto series. First thing we're going to do is we're going to write a Bitcoin miner in Python from scratch. I want to go into the details of what is crypto mining, how you do it, what's happening with it, and then of course we're going to write the miner. After that, we're going to circle back around and we're going to make the hashing module on the FPGA. We're going to write it in Verilog. And then we're going to tie this Python script that we write, replace the CPU only version of the hashing module with our FPGA version. So I'm really excited. If you've liked everything so far, or if you're just catching up with the channel, go and watch some videos and make sure you hit like and make sure you hit subscribe. We've done a lot and we're just getting started. So I really hope that you join for the rest of the videos. All right, y'all take care.